Okay, we're looking at how to rationalize the denominator. Okay, and then we have this question, A, B, C. As I said in the first episode, we're going to be solving question. The first one, 1 over root 5 minus root 3. I've already told us the reason behind rationalizing the denominator. When you have irrational root, irrational number at the denominator, then we need, there are certain steps to be taken. And the step one is to get the conjugate of that expression, because this involves two items, two parts, part one, part two. Okay, and it contains irrational number. It contains roots. Okay, so get the conjugate, as we said, and the conjugate of the expression is the same thing, but the sign must reverse itself. If it's minus, it becomes what? Plus. If it's plus, it becomes what? It becomes what? Negative. Use the conjugate to multiply the numerator and denominator. That's what we have done in this place. Okay? So 1 times the numerator, we have this. Then the denominator is having the same expression, but of opposing sign. This is negative, this is positive. And that makes it to become what we call difference of 2 squared. Please, as you are coming in, begin to type I. Okay, sorry for the break in communication in the first section. Okay, so difference of 2 squared. You take the first one, you square that, minus the second one, you also square that. And I'm trying to buttress that when you have the same expression, but opposing sign, alternating sign, it implies what? The first one, you square that, minus the second variable, you square that. So for this one now, we're going to have, for the denominator, root 5 squared. When you square a root, okay, it's going to give you the contents of that root, minus what? Minus 3. When you square root of a number, it's going to give you the content of that root. So root 5 plus what? Root 3. So that's what we have in that place. That's what we have in that place. The final conclusion will be equal to, this will be 2. This 5 minus 3 is 2. So we can write it as 1 over 2 into brackets, root 5 plus root 3. And that is your answer for that one. This one contains 2 parts. I mean, the denominator contains 2 parts. The denominator contains 2 parts. This one and this one. And one of those parts has roots. Okay? So in such case now, we're going to get the conjugates of the denominator, get the conjugate of the denominator. And that's what? That's a 4 plus root 5. Okay? I told you the conjugate is just the same expression, but you need to change the sign. If the sign is negative, change to plus. If it's plus, you change to minus. Then, now write your question again. Write your question again. And use the conjugates to multiply both the top and the bottom. You have the 4 plus root 5. 4 plus root 5. So use the conjugates of that denominator to multiply the top and the bottom. And that will be equal to what? 3, the first one, times the whole of the brackets. 3 times 4 plus root 5. Then minus root 2 times 4 plus root 5. There's no space there. Let's use this one. So that will be equal to the first one times the bracket, 4 plus root 5. Then minus root 2 times 4 plus root 5. And then over this one, the same expression. Okay, when you have the same expression but alternating sign, the sign is alternating. Negative is here, plus is here. So we call it difference of 2 square, and that will be, you take the first item, the first one here, then minus the second item, root 5, then you square that. You square this one, you square this one. So for the denominator, we're going to have 4 square is 16 minus root 5 squared, that's a minus 5 for the denominator. So that's what we have there. So let's get the expansion for the numerator. Let's get the expansion for the numerator. So which will be equal to 3 times 4, that's a 12. 3 times root 5, that's a plus 3 root 5. Okay. Then minus root 2 times 4, that's a minus 4 root 2. Okay. And then minus times a plus, that's minus root 2 times root 5, that's a root 10, all over 16 minus 5, that's 11. That's 11. Then you check if there is anything addable. If it's addable, you do that. Okay, root 5 is here, root 2 is here, so you cannot combine this one together. Okay, so that's what we have in this case. That's what we have in that case. You can also make it 1 over 11. Then open your bracket, 12 plus 3 root 5 minus 4 root 2 minus root 10. Okay, the question we are looking at, 3 minus root 2 over 4 minus root 5. Then we said that the denominator contains irrational roots. It contains irrational number. So in that case now, we need to get the conjugate of that denominator. And the conjugate will be 4 plus root 5. And then use it to multiply the question, the numerator and the denominator. And that's what we have done here. Then after that, do the expansion. This one times the whole of the brackets is here, minus root 2 times the second bracket, the second bracket. Okay, and this one, the same expression, but alternating sign, which make it to be difference of 2 square. In such case, take the first one, you square that, and then minus the second item, root 5, you square that. 4 square is 16, root 5 square is 5. So if you do the difference, that'll be 11. And that's how we've done that. And then the next thing we did is to do the expansion. 3 times 4, that's 12. 3 times root 5, that's a 3 root 5. Minus root 2 times 4, that's a minus 4 root 2. Minus times a plus, that's a minus. And then root 2 times root 5, that's root 10. And that's end that second part. How to rationalize the denominator. How to rationalize the denominator. Okay. The third one. Let's see the third one. The C part. We have 5 over 2 plus root 5. That's the C part. That's what we have. Okay. So if you look at this one, it contains 2 parts. The first one is real number. The first one is 2, is rational number. The second one is irrational. So once you have irrational, okay, you have roots at the denominator, you're going to get the conjugate of that expression. Okay, get the conjugate of that expression. And the conjugate is what? The conjugate is 2 minus root 5. That's the conjugate. Use it to multiply both the numerator and the denominator. Use the conjugate of that denominator, of that expression of that denominator, to multiply the top and the bottom. Use the conjugate to multiply the top and the bottom. Okay, by so doing, the irrational will turn to rational. And that is a bone of contention, to change the rational at the denominator to rational. We want to remove the roots. Okay, so this is what we now have now. This will be equal to 5 times 2, that's 10. 5 times minus root 5, that's 5 root 5, over. And don't forget, anytime you rationalize, you're going to have the same expression at the denominator, but opposing sign, alternating sign, plus, minus. So in that case now, you don't need to bother yourself to do the normal expansion. It's a difference of 2 squared, and that will be 2 squared minus root 5 squared. Let me quickly buttress that. Note, recall, a minus b times a plus b. Okay, this is what we call the difference of 2 squared. The same expression, but alternating sign. This is plus, this is minus. So what you do is very simple. You just to take the first one, a squared, then minus the second variable, b squared. Minus must connect them if it's a difference of 2 squared. If the expression is the same and they have alternating sign, minus must connect them. And that's what I use for this one. The first one squared, the second one also squared, and minus must connect that. And this will be equal to 10 minus 5 root 5 over 2 squared is 4. Root 5 squared is what? Is 5. And that's minus 1. So we're going to have 10 minus 5 root 5 over minus 1. Okay? And this minus, we go to the numerator and it's going to be minus 10. Okay, and then plus what? Plus 5 root 5. Let me explain that. So it's going to be minus 1 into brackets. So you can leave it this way, but to make it more professional, okay, when you have minus at the denominator, you can take it up. So it's going to be this. You have this one. The denominator has 2 parts, this one and this one. Okay, and each of them are irrational. This is irrational. This is irrational. So we're going to use the conjugates of the denominator to multiply the top and the bottom. The conjugate of this one is root 8 plus root 7. That's the conjugate. So use that to multiply the question. Use it to multiply the question. Use it to multiply the question. Okay? Use it to multiply the question. So we're going to have, if you do that, we're going to have, that will be, look at something now. Do the expansion. This one times this one. That will be 5 root 2 times root 18. That's root 16. And then plus this one, root 2 times root 7. That's a root 14. And don't forget the 5 out. This one, root 8. Square that. Minus must connect that. Then the second one, root 7, 16 is 4. So 4 times 5, that's 20. Okay, plus 5 root 14. 5 root 14. Root 14 doesn't have a perfect square root. Okay, doesn't have a perfect square root. This will be 8 minus 7, and that's 1. Root 8 squared, that's 8. Root 7 squared, that's 7. So the answer is what? 20 root 14. Okay, so that's the answer for that question. I will drop this one at the comment section. This number 2. Do that and feed the answer to the comment section. We have here the first one is to step 1, get the conjugates. Get the conjugates of the denominator, because look at this one. This is a question we are solving. That's the first part, which is irrational. That's roots. We also have the second part, which also what is having a root also. That is rational. So the conjugate is what is root 3. When you're getting conjugate, just have to change this sign. If it's plus, it will change to what? Minus. The same expression, but the sign have to change, have to reverse itself. And then write the question. Write the question and multiply it the top by the what? By the conjugates. Multiply the top and then the denominator also. Multiply it by the conjugates. Multiply it by the conjugates. That's a root 3 plus a root 7. Okay? Root 3 plus a root 7. Sorry, this one is a minus. That's a conjugate. That's a conjugate times the top. Conjugate times the bottom, the top, the numerator, and the denominator. So if you now check now, the numerator is fortunate. Is it a difference of 2 squared? No, it's not a difference of 2 squared. Okay, but the same expression. This one is the same thing as what? As a root 3 minus a root 7 squared. The same as that. 3 minus root 7 squared, because the same thing. Okay, and the denominator will be equal to what? This is a difference of 2 squared. That will be root 3 squared, and then minus root 7 squared. Okay, so I want to quickly explain something to you. Note, we have a minus b squared is going to be equal to a squared minus 2, which I always call invisible. This one, a times b, that's ab, and then plus the last one, b squared. So you can apply that for the expansion of this one. And if it's plus, if it's a plus b squared, it's going to be all plus 2 ab and then plus b squared. So if it is a plus, you have that. So we can apply that. For this one, our a is what? Root 3. And if you square this one, that will be 3. Then minus invisible 2, a times b. A times b, that's what? Root 21. That's a root 21. And then plus b squared. My b squared, that's a 7. That's 7. Root 7 squared. If you follow this one, so this is your a, this is your what? This is your b. All over root 3 squared, that's a 3, minus root 7 squared, that's 7. So that's giving us this one minus this one, that's minus 4. That's minus 4. And then 3 minus plus 7, that's a 10, minus 2 root 21. Okay, that's root 21. If you can use these techniques, it makes your work faster. Okay, it makes the work faster. Okay, and you can do it normal expansion. There's no crying about that. You can do it in normal expansion, but if you can apply this identity, it makes your work faster. In that case, now that minus can go up. The minus can go up and that will be equal to, and then 2 can also come outside here. Let's move this minus 2 up there and factorize 2. So minus 2, I'm taking this minus up. So that'll be 5. Okay, that'll be 5. That's 5 minus root 21. Close your brackets. Over what? 4 is 2 times 2. So this one and this one cancel. Okay, then if you like now, let this minus now comes in, and that will be root 21 minus 5 over what? Over 2, which is the same as what? 1 over 2. Open your brackets, root 21 minus 5. And that ends the solution to that question. That ends the solution to that question. One thing I want to tell you is to solve as many questions as possible. The more questions you solve, you become an expert. You become guru. You become mathematics expert. It's not only mathematics, either physics, chemistry, or any other subjects. The more time you invest in that particular area, okay, you become a different person. Okay, you have more knowledge on that aspect. You become a commander that aspect. Everything needs time. Time is everything. The more time you put in, the better you become. And that is what we are doing in this channel. We are known for that. Any topic we undo, we make sure we back it up with questions. As many questions as possible. As many questions as possible. Okay? Please, as you are coming in, begin to give the videos a thumbs up. If you are yet to subscribe, before you can type anything, you must subscribe. That is a condition. I've already programmed that. Before you can be part of the participants, you must have subscribed. Okay, subscribe straight away. Thank you for doing that, and begin to say hi as you're coming in, and begin to share the links of this video across your social media platform. Thank you, thank you, thank you. Let's talk about root in the second part. So what you do is to get the conjugates. So the conjugate is what? Get the conjugate of the denominator. So the conjugate is root 17 minus root 11. That's the conjugate. Okay? And then use that conjugate to multiply the numerator. Okay? The conjugate, use that conjugate to multiply the numerator, 17 minus root 11. Use that conjugate also to multiply the denominator, with 17 minus root 11. Okay? Why are we doing that? We don't want root at the denominator, and that is the bone of contention for rationalizing the denominator. We don't want irrational number. Okay? Then, as I've discussed the last section, that a minus b squared will give us what? Will give us a squared minus 2ab plus b squared. Let's apply that. Okay? Let's apply that. This one here, this numerator is the same thing as what? Root 17 minus root 11, then square that. Because they are the same thing. It's a multiple. So it's going to be a. My a is what? My a is root 17. So can you square that? Root 17 square minus 2. My a is also what? Times root 17 times b. My b is root 11. Okay, this is my a, this is my b. And then plus b squared. That's root 11 all squared. All over. Okay. The one here, the denominator, is a difference of 2 squared. And that will be equal to what? Root 17 squared minus root 11 squared. Okay? Okay. Minus 2 17 times 11. Root 17 times 11. Calculator. 17 times 11. That will give us root 187. Root 187. Okay, if you multiply that with 187 and then plus root 11 squared, that's a plus 11 over okay, here that's 17. This one here, that's 17 minus what? Minus 11. So we have at the denominator 17 minus 11. I think that's 6. We have 6 at the then 17 plus 11, that's 28 minus 2 root 187 over 6. That's the answer, but we can still take the 2 out. 2 goes at the numerator, 2 goes at the denominator, so that'll be 2 into bracket 14 minus root 187. 6 is 2 times 3, so 2 cancel, 2 cancel, so we have 14 minus root 187 over 3. So you can see now there's no root again at the denominator.